Sorry. Hey, the network was very bad. How are you doing?
Oh, yes, I'm doing well. How are you?
I'll give it to the mic. Okay, so we can start.
Oh, okay, that's
Yep.
great. Let me share my screen really quickly. Okay. Yeah, sorry for the delay, but here are the slides for today. So today we will be learning about atoms and molecules and some of the properties of elements. And we will be looking at the periodic table. And I think, yeah, we gave out two periodic tables. So um, if you have them up on the board, or yes, um, yeah, you can take a look also at the periodic table before we start. So please, yeah, have that ready. Okay. Yeah, let's begin. So today we'll be learning about atoms and molecules, and we will look at some of the um, what's inside the atoms, right? What composes of atoms, and what are molecules, and what composes of molecules, and what types of molecules there are. And we will also look at the periodic tables of elements. We won't look at all types of elements, but like every element, but we will look at groups of elements and some of their properties. Okay. So first of all, let's watch this short video. And this video will explain what atoms and molecules are and what comprises of them. And yeah, um, types of molecules as well. So it can be a pure element or it can be a compound. So this video will explain that.
Are you one of the many people who thinks their bad cholesterol is low enough? It may be too high. If your bad cholesterol remains high, it may lead to an increased risk of heart attack or stroke. Ask your doctor if your bad cholesterol is low enough. Visit badcholesterol.com to learn more.
Let's learn the difference between an atom, a molecule, and a compound. Welcome to Moo Moo Math and Science. The smallest unit of matter is called an atom. Each atom is made up of smaller particles known as subatomic particles. In the nucleus or the middle of an atom are two subatomic particles called the proton and the neutron. The positively charged particles in the nucleus of an atom are called protons. The number of protons in the nucleus is the defining property of an element and is referred to as the atomic number. The uncharged particles in the nucleus are called neutrons. Orbiting the nucleus of an atom is a cloud of negatively charged particles called electrons. The electrons are much smaller in mass than the protons and neutrons. The mass of an atom is based on the sum of the mass of the protons and the neutrons. A molecule is when you take individual atoms and physically connect them together. The atoms are stuck together by either sharing the electrons, which is a covalent bond. A molecule like ozone can be two or more of the same atom. Another example is when you stick two hydrogen atoms to one oxygen atom, you get water. In addition, you have compounds. A compound occurs when you combine elements together chemically. But for it to be a compound, these elements must be different. An element is a pure substance consisting of only atoms that have the same number of protons. Chemical elements cannot be broken down into simpler substances by chemical means. You can find all the elements on the periodic table of the chemical elements. An example of a compound would be sugar. This occurs when you take carbon, hydrogen, and oxygen, and you get sugar. Thanks for watching, and remember, kindness multiplies.
Yeah, so this video talked about atoms and molecules and kind of compounds and what they are, and some of the examples of how they could form as well. But let's start from the beginning again. And like the video mentioned, let's talk about the atom first, right? So an atom is the smallest unit of matter. It's the smallest unit of matter that has chemical identity of an element. So each atom is a certain element, right? And that element is defined by the number of protons inside the atom. So again, atom is the smallest unit of matter that has a chemical identity of an element. And atoms consists of three main subatomic particles. What are these subatomic particles? Well, we've talked about the protons, the neutrons, and the electrons. These are the three particles that makes up an atom. So protons, neutrons, and electrons. Okay. And atoms combine to form molecules. So like we've seen, water can form by bonding with two hydrogen, right? This is a molecule. But yeah, atoms combine to form molecules and make up all substances in the universe. Everything that we can see and touch and smell are made up of molecules, right? Or any elements, right? Mhm. Yeah, okay, I'll move on to the next slide. So yeah, here is a picture of an atom, right? So we can see the protons, right? So the positively charged subatomic particle is the proton. This one, right? It says positive on it. This is positive symbol, right? So this is a proton. And all of these protons, right, are clumped together, right? With this subatomic particle, neutrons, right? Neutrons don't have a charge. So protons have a positive charge, neutrons have no charge. Yeah. So atoms look like this, right? Protons and neutrons are clumped together in the center. Do you guys see this clump? Yeah. It's all clumped together in the center. Yeah, this center is the nucleus, right? And there are electrons orbiting around the nucleus. So here, I've written it down. Protons and neutrons form the atomic nucleus, and electrons orbit the nucleus. Yeah, and electrons are negatively charged. Right? Negatively charged. Okay. Yeah, here is another structure of an atom, right? So you can see there's the nucleus, which is protons plus the neutrons, right, that are clumped in the middle. Yep. The number of protons are positive, number of electrons are negative. So if there are same number of protons as electrons, then the atom is neutral. Mhm. So that is why atoms remain neutral even when individual subatomic particles have charges. And we've already talked about this, right? Protons have positive charge, neutrons have no charge or neutral charge, or electrons have negative charge. Okay. Now this is clear. Let's move on to some question that might have come up in some of the BCE science exams. So this is a quick review quiz. So it says an atom of an element has a neutral charge because what do you think? We've yeah. Does anyone know the answer to this question?
A. A.
Did you say A? This one. Protons and electrons are the same particles. Well, they're not the same particles, right? Um, they are different particles. But there's another answer that more clearly, yeah, explains why an atom is neutral, right? So why might an atom be have a neutral charge?
C.
Are you saying C? Yeah, neutron number and proton number are equal. Yeah, proton number, right? Proton number. Protons have positive charges, right? Protons have positive charges. The neutrons have no charges, right? So that would make the atom positive, right? So we need a negative charge, right? So we don't need a neutron, right? If we have a proton, then what else do we need? Yeah, no worries. You can try again. Yeah. I think I heard B, or did you say B? Yeah, yeah, okay. Yeah, that's correct. The answer is B. Yeah, because proton number and electron number are the same, right? So it's not A because protons and electrons are not the same particle, but I think you meant the proton number and the electron number are the same, like the numbers of protons and electrons. So yeah, that is why the answer is B. Yeah. Number of protons, positive charge equals the number of electrons, then the atom is neutral. So B. Yeah, great job, everyone. Yeah. Okay. Let's try number two. The two main particles in the nucleus of an atom are what? Yeah, A does everyone agree with A? Yeah. Yeah, that's right. The answer for number two is A. Yeah, neutrons and protons. So yeah, inside the nucleus, the center, there are neutrons and protons, right? Yeah, great job. And number three, okay. This one is a little bit difficult, but it says an atom has 20 nucleons and 9 protons. What is its neutron number? So nucleon is actually the proton number plus the neutron number. Yeah, I'm hearing C, and that is correct. Yeah, because 20 nucleons means there are 20 protons and neutrons. So if you have 9 protons, then you have 11 neutrons, right? Just subtract 20 minus 9, and then you get 11. Yeah, I think BEC, the exam loves to ask the question about nucleons, right? So always remember what a nucleon is, right? Is a combined number of protons and neutrons. So always remember that. But yeah, great job. The answer is C. Mhm. Okay. So now that we have kind of walked through the quiz, let's get into a specific atom, right? Let's get into an atom called carbon. Carbon, the symbol is represented by C. Carbon has a symbol of C. And what is this number here? 6. This number 6 is the atomic number, right? The atomic number. Number 12, right here, this shows the atomic mass, the bottom one. Okay. So, since atomic number equals the number of protons, carbon has a proton number of 6. Carbon has electron number of 6 because proton number and electron number need to be the same, right, for carbon to be neutral. There are 6 neutrons in carbon, and we can tell the number of neutrons by the atomic mass. Atomic mass of 12 shows the total number of nucleons, right? So 12 minus 6 is equal to 6. So there are 6 protons, 6 electrons, and 6 neutrons in a carbon atom. Okay. So yeah, this is the carbon atom. And yeah, this is just one example of one type of element in the periodic table. But in the periodic table, there are more than 100 elements, right? You don't need to memorize all of them again, but we will get into um, grouping certain elements together and looking for properties of those elements, right? So I think, yeah, once you're finished writing down, I think we can move on to the next slide. Okay, moving on. Okay. So yeah, let's quickly talk about molecules before we get into the periodic table. So molecule is a group of two or more atoms that are chemically bonded together. So two or more atoms that are simply bonded. These atoms can be the same element, right? Such as oxygen gas, O2. Right? There are two oxygens bonded together, an oxygen gas. Or these atoms can be different elements, like water. H2O is water. There are two hydrogens and one oxygen to make up water. And molecules have their own physical and chemical properties. Right? So they're different from the properties of an element because now they're a new molecule. And molecules are electronically neutral charged. Right? They are neutrally charged. Okay. Yeah, let's move on to the next slide. So again, here are just two examples of a molecule that consists of same elements. Like this is oxygen right here, oxygen gas, O2. This is ozone or O3 that make up the ozone layer of our atmosphere, right? O3. So these are all made up of oxygen atoms, right? But water molecule, we can see, consists of two hydrogen and one oxygen bonded together. And these are an example of different elements bonding together. Okay. Yeah, let's since we're on the topic of molecules, let's answer this question really quickly. So how many atoms are present in H2O2 or hydrogen peroxide? Yeah. Four, right? Yeah. This is simple. Yeah, great job. The answer is four. There are two hydrogen atoms and two oxygen atoms bonded together. So remember that in a chemical reaction where it forms hydrogen peroxide, no atoms are lost. So we keep the four, two hydrogens and two oxygens. Yeah, great job. Okay. Yeah, so types of molecules that we formed, right, are elements and compounds. So an element, right, is the pure substance made up of one kind of atom. So we've already talked about this, right? So pure substances are things like O2, hydrogen, gold, or carbon. All of these things that have one type of atom are called elements. and elements are listed in the periodic table by their atomic number, which is their proton number. And we will look at the periodic table in just the next slide. But also, we've talked about the compound, right? Compound is made up of two or more kind of atom. So, the water that we've talked about before that has two kind of atom, that is a compound. Water is a compound. But things like oxygen gas or ozone is a pure substance, right? It's made up of one kind of atom. Okay, I think once you have finished, I will be moving on to the next slide. Since we have a couple of more slides to do today. Okay. All right. So again, these are elements versus compounds. So elements contain one kind of atom, like helium or oxygen, O2, and compounds contain two or more kind of atoms. So like water, H2O. There's H hydrogen and O oxygen. There are different kinds of atoms, so they are compounds. Okay. So now let's finally get into the periodic table. So we will look at how we can use the periodic table, right? And what types of elements there are, right? So there are all these periods and groups, right? So we will learn about what they are and what some of their properties of these groups are. So let's watch this video that will tell you more about it.
It's your show, princess.
Will everyone just cool it with that? Listen up to me.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about reading the periodic table. Periodic table gives you lots of information about the different elements. Let's get started with carbon. If you'll notice carbon, it has an atomic symbol of C, which is the capital C. Let's first focus on how to find the number of protons, neutrons, and electrons. The number above the atomic symbol is the atomic number. In this case, it's a 6, so it tells you that it has 6 protons. Protons have a positive charge and gives the elements its properties. It can never vary. Next, let's figure out the number of electrons. Unless the element is an ion, which means it has a positive or negative charge, it will have the same number of protons and electrons. So since you have 6 protons, you will have 6 negative electrons. Next are the number of neutrons. You'll notice, you will see under the C is a number 12.0096. That is the atomic weight. It's the weighted average of the number of isotopes. But you need the mass number for the number of neutrons, so you will round it to its nearest whole number, in this case 12. Then you can use the formula mass number equals protons plus neutrons. So you have a mass number of 12, you have 6 protons, so you need 6 neutrons. Now a couple of extras. Notice the color of the background. There is usually on a periodic table a key that tells you what the different colors stand for. In this case, the green is a polyatomic nonmetal. And also, the atomic number can be different colors. In this case, it is black, and the key tells me that this is a solid. And finally, you can look and see what column it's in, and it will tell you its family. Elements in the same family have similar properties and the same number of electrons in the valence levels, except for the elements in the middle. Okay, let's look at another example. Let's look at boron. Boron has a symbol B. It has an atomic number of 5, so it has 5 protons, so it will have 5 electrons because it's neutral in charge. It has a mass, it has an atomic weight of 10.806, so I will round that to 11. Then 11 equals 5 plus 6, so it has 6 neutrons. It is a metalloid based on its color. It is a solid, and it is in family 13, so I know that it has 3 electrons in its outer shell.
So this video talked about using the periodic table and using the numbers that are on the periodic table in order to find out the number of protons, neutrons, and electrons, and the type of group they are in. And we can guess, based on their properties, how they would react. So that's how we can use the periodic table. So again, we went over this, right? So carbon over here, this is atomic number. That tells you number of protons and number of electrons. In the middle, there is a chemical symbol C for carbon. And at the bottom, there is the atomic mass of 12.01. And this is protons plus neutrons. Protons plus neutrons is the atomic mass or atomic weight. Right. And yeah, here is a bigger picture of the periodic table. And I think, yeah, you guys have a periodic table too, right? In the walls that you've hung up. So you can also look at that as well. But this is the same periodic table. And we can see, the numbers that are increasing as they go from left to right. So hydrogen is 1. He, this is helium, is 2. And then it goes down here, like 3 lithium, 4 beryllium, 5 boron, etc. So it goes from left to right as the number increases, right? And then it goes down the period as the number increases, right? So 1, 2, and then down here, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, and so on. Yeah. So that's how the atomic number increases in the periodic table from left to right and then down. All right. And we can notice other kinds of groups as well. Right? It's talking about the alkali metals, which are here, alkaline earth metals, and then many more like transition metals, halogens, and noble gases. But yeah, we will get to them in just a bit. But this is the periodic table that you should be pretty familiar with, or yeah. Okay. So let's look at this short question as well. So the periodic table is an arrangement of elements according to increasing what? Yeah, did you say A or B? Okay, I think I heard A, and yeah, that is correct. Yeah, great job. It's increasing by the atomic number. So the mass number can increase, yes, but it says the arrangement of the periodic table of the elements, right? Why the specific order of elements? And that's because of the atomic number and not really the mass, right? So the atomic number decides the arrangement of the periodic table. Yeah, great job, everyone. So now let's look at some other kind of groups that we have, right? These are larger groups, right? So these are clumps of groups that we can consider them as metals, right? Metals, metalloids, and nonmetal. These are the three types of elements, largely, in the periodic table. So you can notice the metal groups that are in the color purple. Color purple, they are metals. Metalloids are in green. So green, so right here. Non-metals are this bronze color, right? Which is here. Yeah, these are non-metals. And these are important because metals, metalloids, or semi-metals and non-metals all have different properties. They all have different properties. That's why it's important to know about them. So metals, let's talk about the properties of metals. Metals are found on the left and center of the periodic table. They are often shiny or lustrous. They are very good conductors of heat and electricity. Metals are malleable, meaning they can be flattened or shaped, by a hammer or something else. And they are ductile, meaning they can be made into wires by thinning them. Metals are usually solid at room temperature, well, except for mercury, which is a liquid at room temperature. And metals tend to lose electrons in reaction, right? So metals tend to lose electrons in reactions, mostly in forming ionic bonds with other nonmetals. But yeah, we will get to that shortly. But know that metals always lose electrons in reactions. Okay. Some example of metals are like platinum, copper, iron, and gold. These are all metals. So, yeah, let's get into the nonmetals. Nonmetals are elements that do not have the properties of the metals. They're found on the right side of the periodic table. Well, except hydrogen, which is on the very top on the left, but it's still a nonmetal. Nonmetals are usually poor conductors. They're not shiny, and they're brittle when solid. That means they break easily without being able to change their shapes. Nonmetals can be solid, liquid, or gas at room temperature. And they tend to gain electrons in chemical reactions. So nonmetals tend to gain electrons. Right? So now let's get into the metalloids or the semi-metal. Oops, sorry. The semi-metals. So these metalloids or semi-metals have properties of both metals and nonmetals. And semi-metals are things like silicon, boron, arsenic, germanium, and more. And they are semiconductors, meaning they conduct electricity better than nonmetals, but not as well as metals. They can be used in computer parts, smartphones, and other electronic devices because of this behavior. So metalloids can be very, very useful. Mhm. Okay, so now let's move on to our next slide. Okay, so we will be looking closely at each individual group's or family in periodic table. So far we've just talked about the metals, the nonmetals, and the metalloids as larger groups, but we will talk about the groups in smaller, in each column, which are families of elements. All right, so let's watch this video.
A better way to bank, a sweeter way to sip. Stop by this summer and enjoy everyday banking 7 days a week. Capital One Cafe. Part bank, part cafe. The perfect twist.
I'll just go ahead and warn you up front that this will be a lame joke, like most science jokes, but stay with me anyway. Please. Okay, here we go. Do you ever wonder where the chemists have their lunch? They have it on a periodic table. We've spilled some information about periods of the periodic table. Now let's move on to groups. Groups are the vertical columns in the periodic table. Much like in periods, elements in the same group will have similar properties, and are given numbers that indicate the number of electrons in the outermost shell, or valence electron, of that element's atoms. This means that all atoms within a specific group will have the same amount of electrons on their outer shell. For example, all of the elements in group 1 will have 1 electron in the outermost shell of their atoms, while all elements in group 2 will have 2 electrons in their outermost shell. This information is incredibly useful for classifying elements into their appropriate groups based on the number of valence electrons. The classification from the left column, or group 1, to right, group 18, also informs us about each group's specific properties and their names. Group 1 are called alkali metals, and group 2 alkaline earth metals. They are called alkali because they create an alkali solution when reacting with water. Alkali metals are shiny, soft, and more reactive than the elements in Group 2. Both groups reside in the 2 leftmost columns of the periodic table. Now, let's explore the middle blocks, which are known as the transition metals. The precise boundary between the main groups and transition metals remains a topic of debate, but they generally span from Group 3 to Group 12. The term transition refers to the transitional nature of properties between typical metals and nonmetals. The elements in this block, excluding group 11 and 12, exhibit excellent conductivity, have high melting and boiling points, and are hard, strong, and malleable just like metals. However, it also has the ability to form colored compounds, such as in precious stones, and some are immune to corrosion, such as gold from group 11. They offer a fascinating subject of study due to their various behaviors and applications. Our next group is halogens. Halogens are recognized by taking part in displacement reactions and the salt formation when they react with alkali metals. For example, kitchen salt. The halogens are among the most chemically reactive elements in the periodic table, in contrast to our next and last group, the noble gases. The noble gases, also named as Group 18 or 0, are the most stable group in the periodic table. All other elements react to attain the stability exhibited by the noble gases. These noble elements are incredibly unreactive and can even be used to prevent reactions from occurring. Now, I'm sure you have a better understanding of what groups in the periodic table are and the properties they convey. But there's more to explore in our next episode, so be sure to subscribe.
Yeah, so I just wanted to share this short video because I think it shows, all these different groups in the periodic table. And it showed us some of the properties of those groups too, right? Whether some are reactive and some are very, very stable. Yeah, let's review that again, right? Okay, let's start with the alkali metals. In the periodic table, this is the first column. The first column is called the alkali metals, or group 1A. It has 1 valence electron, meaning that it has 1 electron on its outermost shell. So just know that for now. It has 1 valence electron. Valence electron means electron on the outermost shell. Okay. And alkali metals, this first column is very, very reactive. And alkali metals are lithium, sodium, potassium, rubidium, cesium, and francium. These are all alkali metals. Now let's get into the second group, or the alkaline earth metals. These are group 2 or 2A. Alkaline earth metals have 2 valence electrons. Again, valence meaning the outermost shell. And it is also very reactive. it's not as reactive as alkaline metals, but alkaline earth metals are also very reactive. Next we had the transition metals. So transition metals were the groups from 3 to 12. 3 to 12. These are all transition metals in the middle. Oops, I didn't mean to have two valence electrons since that can vary a lot in the middle. But just know that there are various transition metals and their properties also vary. So these are transition metals. And we've also looked at halogens, right? Halogens are group 7A right here. They have 7 valence electrons and they are very reactive. And this group is the halogens. Okay. And then finally, there are the noble gases. The noble gases, also called as group 8A. 8A. They have 8 valence electrons and they are very stable. So unlike other metals or halogens like nonmetals, noble gases are very, very stable. And the reason for that is because they have 8 valence electrons. That's the most stable form or the stable number of electrons in the electric shells. So, yeah, these are the noble gases. The very last column of the periodic table. Yeah, so one of the final topics that we will talk about today are the electron shells. So when I said valence electrons, that means they are on the very last electron shell, outermost shell. So what are electron shells? Well, electrons orbit the nucleus in layers called shells. And each shell can hold a certain maximum number of electrons. The first shell can hold up to 2 electrons. The second shell can hold up to 8 electrons. And the third shell can, no, it's not 18, can also hold up to 8 electrons and so on. So starting from the second shell, each shell so on, so the fourth, the fifth, and sixth all can carry up to 8 electrons, right? And again, the outermost shell is called the valence shell. That's what I was referring to when we looked at the groups in the periodic table. And it plays a key role in chemical bonding and reactivity. if you finished, writing this down, then I can move on to the next slide. Okay. So these are what the shells look like, right? So we have first electron shell with 2 electrons, right? 2 electron. Second shell has 8 electrons, and the third shell also has 8 electrons. It can hold up to 8. Now, but what are stable atoms? An atom is stable when its outermost electron shell or the valence shell is full, right? And this can be a bit difficult to understand, but just know that once the valence shell is full, then the atom is stable or non-reactive. So if an atom has 2 electrons, then it is stable. If it has 8 electrons on the second shell, then it is stable. And the third shell, if it has 8 electrons in the valence shell, then it is stable. And most atoms try to have 8 electrons on their outer shell. And what are the groups that have 8 electrons in their outer shells? It is the noble gases, right? Which are already stable. So remember that atoms want to be stable, and a stable atom is a one that has an electron shell that is full, the valence shell that is full. That is a stable atom. So that leads to certain formation of ions, right? So now we get into some ions. This might come up in some of the BECE exams, so that is why I am teaching you guys this. But just know how ions are formed and how they can react. Right? Let's look at sodium. Sodium. Sodium has atomic number of 11. Does anyone know what the proton number and the electron number for sodium is? Yeah, can anyone tell me what is the electron number for sodium? Yeah, I think I heard 11, right? Sodium has 11 electrons, right? Because the atomic number is 11. And the atomic number shows the number of protons and electrons. So it has 11. Based on the shells, right, that we've learned, sodium has 2, 8, and 1 electrons organized in the shell. 2 out of the 11 electrons fill up the first shell. The 8 electrons fill up the second shell. But 2 plus 8 is equal to 10, right? It has 1 extra electron, which sodium puts in the third shell. So in the outermost shell, or the valence shell, sodium has 1 electron. So sodium tends to lose 1 electron to become stable, to get the 2-8 structure. Mhm. Remember, 2-8 is very stable. 2-8-8 is also very stable, and so on. Always remember this structure. Let's look at another example. So chlorine is in group 7A. Chlorine is a halogen, right? Halogen. So we know it has 7 valence electrons. Right? So chlorine has 2, 8, 7 structure. Mhm. So can anyone tell me, um, does chlorine need to gain or lose electron? Gain or lose to become stable? Yeah, gain. Yes, gain. It needs to, yeah, right, gain an electron. Yeah, that's right. Great job. Chlorine needs to gain 1 electron to add to this last shell. If you gain electron, then chlorine becomes 2-8-8. 2-8-8, which is a very stable form. Okay. Yeah, great job, everyone. Thanks for following. And yeah. So now we talked about, yeah, gaining and losing electrons, right? And there are names for these ions. So whenever an atom loses or gains an electron, they are called ions. Ions.
They are called ions.
Yes, right. Ions are when you lose or gain electrons. Mhm. Yeah. When you lose an electron, then it forms a cation. When it gains an electron, it becomes an anion. So again, if you lose an electron, right, it'll be more positive, right? So more positive means a cation. If it gains an electron, the atom will be negative, right? Because electrons are negatively charged. So these are just two different names of ions that can form from a neutral atom. Again, loss of electron means cation. Gain of electron means anion. Right? Always remember that. Losing electron, cation. Gaining electron, anion. All right. Good. Okay. Yeah, let's look at more example. Right? Let's look at sodium. Mhm. Sodium. Let's start that from, yeah, sodium. Okay, sodium has how many atoms? Okay, let me go back to the periodic table. So where is sodium? Do you guys see sodium, Na, on the periodic table?
Yes.
Yes. Right. Where is it?
All right.
Yeah, which number do you think?
Number 11.
Yes, right. Number 11. That's
Yes.
sodium. Yes, that's right. You found it. So it has how many electrons does sodium have?
11 electrons.
Yes, that's right. Sodium, great, that has 11 electrons. Yeah, let's go back. Yeah, great job. Let's go back to our slide. Sodium, we learned, has 11 electrons. Okay, so it fills up the first shell. It has 2 electrons. First shell complete. Yeah. The second shell has 8 electrons, right? Hmm?
1.
And then 1, right? You say 1? Yeah. 1.
Yes.
Yeah, great job. Right. So it has 2, 8, 1.
1.
Yeah. And if sodium forms an ion, sodium ion, will it gain or lose electron?
Please come again.
Yeah. Will sodium gain or lose electron to form a sodium ion? Remember, sodium ion is stable. Yeah, will it, yeah, gain or lose electron? What do you think?
Lose.
Did you say, yeah, lose? Yes,
Yes.
that is correct. Yeah, right. It'll lose electron. Right? So this will become 2, 8, right?
8.
Yes, great job. And 2, 8 is very, very stable. It is
Yes.
stable, yes. So that is why sodium ion will lose an electron. And what is this ion called when you lose an electron?
Anion.
Yes,
No,
yeah, that's right. No, yeah. Oh, yeah. If you, yeah, lose an electron, that's cation. You corrected. Yeah, that's great. Yeah, amazing. Yeah. Hmm. So, yeah, over here again, losing electron is
I.
cation. Yeah, great job. Hmm. Amazing. Yeah.
Yeah.
So let's look at fluorine again. F, this one. We don't need to go back to the periodic table. We can just count the electrons here, right? From this diagram. Yeah. So it has 2 and how many on the second shell? The valence shell.
7.
Yes, right. 1, 2, 3, 4, 5, 6, 7. Yeah, it has 7. So will fluorine gain or lose electron?
Gain electron.
Yes, gain 1 electron, right? To
Yes.
form, yeah, fluorine ion, which will be 2, 8. Again, this is very stable. And fluorine wants this. Okay. And what is gaining electron called? What ion?
Anion.
Yes, that's right. This is called an anion. Yeah, amazing. Yeah. Yeah, great job. Mhm. So these are just examples of ions forming. Yeah, amazing. Let's move on to the next slide. And we can infer based on the periodic table what kind of ions it will form. Right? Remember that group 1, this column, all had 1 valence electron. Right? Yeah, all this group 1 has 1 valence electron. Yeah.
Wow.
All of them, all of these groups, elements in this group, will lose one electron. Yeah, all of these group will lose one electron. Yeah, same with this one, this second group. Second group. These groups will lose two electrons. Yeah, the second group will lose two electrons because they have two valence electrons. And you can confirm this too. You can manually draw. We saw that sodium loses one, right? Yeah. So all of this group in this column loses one electron. How about this group on the right? This group. Is this group 17 or group 7A? All of these atoms tend to gain one electron. They tend to gain one electron. We've looked at F, right? Fluorine, yeah, before. And we saw that it gains one electron. And same is for chlorine, bromine, and all of these other groups. They all gain one electron. Yeah, and you can see how useful the periodic table is. You can just
Yes.
look at yes, it's very useful. You can look at the column and then tell what ions they form. Yeah. Can look at that just from the periodic table. And what about this last group? Do you remember? These last group. They are called the noble gases, and they are already stable. Right? So the last group does not form an ion. Yeah. This last column does not form an ion. It is already stable. So yeah, always remember that.
Okay.
Okay. Yeah. Okay, yeah, this is an easy question for you. But when an atom loses an electron, the ion formed is
It's
Yeah, hello, David.
yes, hello.
Yeah, sorry to interrupt. We had
Yeah.
a power outage just right now, and
Oh,
when
okay.
it just went and came back, and our speaker is no longer working. So we find
Oh,
it difficult to hear what you're saying. The
oh,
power
okay.
just flash and it's it's no longer working again.
So the speaker is not working, right?
Yeah, yeah.
Oh, oh no. Okay. We only have like a two more slides left, so I think we can finish for today.
You there?
Yeah. Sorry, I think we have like two more slides for today. So I think
Uh,
can we, if you finish this
okay,
without the
okay.
speaker, if that's
So,
okay? Yeah.
all right. Then they have to be very quiet. Then you see if you can finish it. I'll be attending to the speaker and see if I can fix it.
Okay.
Yeah.
Yeah, it'll be really short. I think I can finish in 5 minutes. So
Okay.
yeah.
All right.
Mhm. Okay. Yeah, thank you.
You're welcome.
Yeah, and you said cation, right?
Yes.
Yes, that is correct. And yeah. Yeah, this was on the BEC exam, so I think you will be very, yeah, well prepared. Yeah. Mhm. Okay. So this one is a little bit more difficult, but an atom X forms bond by losing one electron. Right? The charge on the ion formed is what? It's losing one.
Die. Baby. Oh, it's good. Yes, yes, yes. Ah. Giáo, giáo. Mẹ sao bảo? Nó sao bảo? Để tôi được. Nó là D.
Do you think D or this one?
No, B.
Oh, do you say B?
Yes. Yes.
Oh, losing one electron. So, yeah, let's see. So, losing one electron, right? If you lose one electron, then the atom becomes, does it become negative or positive? Yeah, no worries. Yeah, if you lose an electron, yeah, then okay, the ion becomes positive, right? Mhm. So it's
Please
losing
come
one.
again.
Yes, if you lose one electron, then the ion becomes positive, right? Not negative. So what do you think the answer is? It's not B. Uh,
I D what? Is D.
it's losing one electron. One. So this is plus two, right? Mhm. So yeah, that's right. It's gonna be C, right? Because yeah, it is losing one electron. So
Cái này gạt cái này chia ra thì nó sẽ này.
if you lose one electron, then the ion becomes one positive. Right? Mhm. Losing one electron means it becomes one positive. Okay.
Please, I don't understand.
Oh, you don't understand why it is C? Yeah, let me explain again. Um, so,
Please, I don't understand.
oh, okay. Yeah. So it says the atom loses one electron, right? And what charge is an electron? Is it? It's negative charge, right? Negative. Yeah, electrons are negative. So if you lose one negative, then the atom becomes one positive, right? So if you lose a negative, then the atom becomes more positive. Let's have an example, right? Let's have carbon. Carbon. Carbon is not a good example, but um, let's have like oxygen, right? Oxygen. Oxygen has, we can actually go back to, the periodic table but oxygen actually has 8 electrons. Mhm.
Yes.
Yes.
So,
oxygen has 8 protons and 8 electrons.
Yes.
Yes, right. If you lose 1 electron, or oxygen actually doesn't lose electron, but let's say it does, right? Let's say it does. If it becomes 7 electrons and 8 protons, right? Oxygen has more protons than electrons, right? You can put it 2. So 8, positive 8 minus 7 charge is equal to positive 1, right? So it's positive 1 right here. Yeah, does this make sense for you? Or
Yes. Yes.
okay. So again, it has more protons than electrons, so that is why the ion formed is positive. But it lost 1 electron, so it is 1 positive. Charge on the ion formed. It has to be formed.
Yeah.
Okay. All right, let's get to the let's get into this last question. I think, yeah, this one is the most difficult question in this slideshow. Yeah, so you say B, right? So I did put y is equal to 2 here, but let's see how we got 2. How did we get 2? Aluminum has 13 electrons. Right? Yeah, so it's 283. Aluminum loses 3 electrons. So aluminum ion is Al3 plus. This is aluminum ion. Right? 283. So aluminum loses 3. So Al3 plus. Okay. What about sulfur? 16, right? Atomic number is 16. It has 16 electrons. So it forms 286. 286. To form 288, sulfur gains 2 electrons. Right? Sulfur gains 2 electrons. So sulfur ion is S2 minus. Yeah. So we have Al3 plus and S2 minus. And we know that it is AlYS3. So it has 3 sulfur ions ready, right? We need to match that with aluminum ion. So 3 times negative 2 is negative 6. So S3 has negative 6 charge. So ALY should be positive 6 to become neutral. So it is 3 times Y is equal to 6. And what is Y? It is 2, right? Yeah, Y is equal to 2. So that is why the answer is B, Y is equal to 2. Yeah, does this make sense for everyone? Or I can explain this one more time if you want, but uh, yeah, does this make sense?
Please explain it one more time.
Okay, I can do it one more time. Yeah. Yeah, do you understand up to this point? Aluminum forms free, yeah, Al3 plus. Yeah. Sulfur ion is S2 minus. Do you understand up to this part?
Yes.
Yes, okay. So we know Al3 plus and S2 minus. And we have AlYS3. Right? That means it has free sulfur ions and Y number of aluminum. We don't know why, but we know there are 3 sulfur ions. Sulfur ion has a charge of -2. -2. There are 3 -2, so that's why we did -2 multiplied by 3, which is -6. -6. Aluminum has +3. So aluminum, write that here. Aluminum has +3. That's aluminum. And how many aluminums do you need to make it +6? So each aluminum has +3 as charge in the ion. Yeah. To have +6, you need 2 aluminum ions, right? 2. Because 3 times 2 equals 6. Right?
Yeah.
Yeah, so that is why you need 2 aluminum. So Y should be equal to 2. 2 aluminums. Yeah, I hope this makes more sense. Um, yeah, I will actually send you the slideshow as well, so you can take a look and try to resolve it yourself. But yeah, I think that is the end of my presentation. But do you have any other questions for me today about anything we learned? Yeah, any other questions?
Any questions? Oh,
Okay.
so what is saying? They said they have no question.
Okay. Yeah, I think that's fine.
Right.
Yeah.
Thank you very much.
Yeah, thank you, yeah, everyone for listening.
All right.
And I
Yeah.
think
So see you next week.
yes, it's starting, yeah, next week we will continue more of our science lessons. So yeah, I think we will,
All
yeah,
right.
continue with chemistry. Okay. Mhm. All right. Yeah. And thank you and see everyone next week then. Yeah. Bye everyone. Bye.
And
Bye everyone. Bye bye.